Yes, in this situation, students, in scenario 2, you will add the data first. Peter will be added here first, and then top of stack pointer will be incremented by 1, right? Okay, so quickly answer, students. If I want to say over here in this particular scenario, if I want to say array name brackets top of stack. Okay, so if I say over here output, what is going to be the output, students? For scenario 1, output array name top of stack. What would be the output? Yes, good. It is going to be outputting Tom, right? So this will output Tom. And if I want to say output top of stack, what will be the output, students, in this case? So we want to evaluate the value of TOS. Very good. It's going to be 3. Very good. So you should know how to use these terms in your pseudocode. So whenever you want to use the element, you will use this in your pseudocode. And whenever you want to use the index, you will use the top of stack pointer. Very good. So now we will move on. This was introduction. And now I'll show you one error in the past paper question. Okay. So if you have any queries regarding stacks, you can ask me at the end of the class. You can stay back and you can ask me if you have any queries regarding the basic concepts of top of stack. So pop would mean removing an item, and the item will be retained from the array name top of stack like this, and then decrement the top of stack by 1 whenever we are talking about pop. Okay, so there is an error in this question. This is November 25, paper 2 variant 3, question 3. Have a look at this question, students. Quickly go through the question, read it on your own. I will be sharing this PDF at the end of the class. Okay, so don't worry, you will get the PDF of this screen that you're viewing in front of you. Okay, so what is the name of the stack pointer, top of stack pointer? What is the name? Yes, very good. It is SP. Yes. So students, note that SP is the name, the name of the stack pointer. This is given in Courier font, and over here you have to note that if the stack is empty, the top of stack pointer, which is the stack pointer SP, is assigned the value 0. Okay, why 0? Because the array starts from 1. The lower bound given is 1. And stack consists of integers. So please remember, this is not a question of array of records. Okay, so as soon as you see an array and as soon as you see a record, it is not always an array of records. This is an array of integers. Okay, an array of integers. The first item added to the stack will be stored in this stack brackets index 1. So the first element will be stored in this stack brackets index 1. Okay, so we are talking about a function pop, and pop will be used to remove an item from the stack. So please note it down that stack pointer is assigned 0 if the stack is empty. And I want to remind you, whenever you want to remove an item from the stack, first of all, you have to check whether the stack is empty or not. So I'm just reminding you, and let me write it down over here. So a quick reminder. If we talk about stack, queue, or linked list, the first thing is to add an item. You have to check if the structure or the array, if the structure, if the stack, queue, linked list, if the array is full or not. If the array is full. If the array is full, output error message, right? Output error message. And if you want to delete an item, what you should check? You should check if the array is empty or not. If it is empty, then output error message, right? Because you cannot delete anything from an empty structure, and you cannot add anything to the structure when it is already full. So whenever it's a question of describe or pseudocode, these are quick reminders that should come to your mind. This is what you have to check even in the theoretical description questions. Are you clear about this much, students? Any questions so far? All right, so let's move on. Okay, so this is what we were talking about. We have a record, and what is the record name, students? What is the record name?
Pop data.
Very good, it is pop data. All right, so when we have pop data, so look at this pop data. Pop data is, I'm just reminding you, pop data has two fields. What are the two fields? Data and exists is Boolean. So data is integer and exists is Boolean. I'm going to write it down for you over here. So let's complete this. And I'm going to write the record for you over here. So we will have the syntax. What is the syntax? The syntax is variable dot field, right? And array name index dot field. This is what we have for our syntax, right? So students, we are returning the record pop data, and pop data had two fields. The type pop data had declare data. And what was the data type of data? It was integer. And the other one was exist. Was Boolean. So this is the information that was on the previous page, and type, right? So now students, there is an error in the question as well. All right. So declare this pop colon data type and return this pop, So what is going to be the data type of this pop? What do you think, students?
Miss, would it be integer?
Miss,
Okay,
would it
so
be pop data?
yes, it is returns pop data. See, returns pop data and return this pop. So what is the data type? Returns pop data, return this pop. This means this pop is of data type pop data. Pop data. Okay. So this is fine. No errors up till here. Then what will happen? If dash, then stack is empty. What was indicating stack is empty? Yes, students, what was indicating that the stack is empty?
If SP is equals to 0.
Yes, if SP is equal to 0 was given on the previous page, which I was highlighting, that if SP is equal to 0, then it indicates stack is empty. And pop data dot exist is over here, it's given let me just scroll. Okay, over here it says if the value removed from the stack data is assigned to data, then exists is set to true. If it is not possible to remove a value from the stack, then exist is set to false. So now exist will be what? Exist will be set to, what do you think, students? Quickly write it down in chat.
Won't it be false?
Yes, it would be false, right? Good. So it is going to be false over here. Now, please tell me, students, over here, pop data. What do you think? Over here, should it be pop data dot exist? What do you think? What do you think should be here? Pop data dot exist? Do you agree with this? Do you agree with this point? Pop data dot exist? You have everything on the screen over here. Pick up the error.
Wouldn't it be pop data index?
No, we have a variable only.
Okay.
Definitely this was a variable over here. This is a variable of type record. This pop is a variable of type record, and have a look at this, that we have variable dot field. So is this variable dot field? What was the name of the variable of type record? So it's not going to be pop data. Instead of pop data, it should have been, yes, students, quickly write it down in chat. This pop. Yes, this pop, right? So over here, actually, it should have been this pop dot exists. Okay, so this is the error actually. Okay, it should have been variable dot field, and variable is this pop, not the data type. Pop data is the data type actually. So over here, thank God there were no errors in the blanks, but only the pseudocode that they had written for you, it had errors. So this was November 25, right? So, but you would understand what they're trying to say. From the record, this is the record that we have. From the record over here, you would know that data you have to populate. So what is the data, students, that will be coming? The array name, and in the brackets, it would be. So let me go back to the previous page to look at the array name. What is the array name? The data is going to be coming from the array, and the array name is this stack. Can you see this stack, students? This stack is given. This stack is an array of data type integer of size 30, right? So, and can you see they have given you an example over here? This stack brackets 1 has the first element. So we will write down this stack brackets SP. This tag brackets SP would have the data. So over here, we will have this stack brackets SP. Okay, so this will have the element. Just now we had discussed how the array name top of stack pointer will give us the element that we want to fetch for pop, and the element that we want to store for push. Now exist would become true. This will be set to true. And SP, what would happen to SP? How do you think SP would be updated? This is the stack pointer. So actually we are talking about SP, which is the stack pointer. Students, please write it down in chat.
-1?
Yes, SP -1. Not only -1, but SP -1. Good. SP -1 would mean decrement the stack of top of stack pointer by 1. Are you clear about this, students? So over here, if I say this is wrong and this is wrong, instead it should be this pop. Are you all clear about the concept? Shall I move on, students?
Yes, miss.
All right. So now let me just clear all of this and move on to the next question. Okay. So over here, Linear queue. Now, next data structure is going to be linear queue or circular queue. This is the first thing that should come to your mind, students, whether the question is about linear queue or circular queue, because your answer would change, right? So over here, how many elements are there in the queue? So we can see that there are 4 elements in the queue, and the first element is red. And please note over here, I have written it here in the text box, that array name front is going to be red, which is the element, and front is the pointer, which is pointing to index 5. All the pointers would be integer data types because they are storing the index. So front is storing the index 5 and the element is red. And how to access this particular item, element, array name, brackets, front. And what was the recently added data, students? What was the recently added data? The last data. Yes, it is pink. So this means whenever we have a queue, for example, students are standing in a queue at the canteen, the new student will be added from front or the new student will be added from end. What do you think? The new student would be added from the end. Very good. From the rear, from the end. Very good. And new students will be added from the end, and the students will be removed from the queue at the canteen from the front. So this is something that will not change. This fact will not change. New students will be coming from the rear pointer or from end, and the students will be removed. The data will be removed from front pointer. This is how it happens at a queue, at a queue at the canteen, where the first student who had joined the queue will be removed because they have been served. Now, in removing the item, students, in removing the items, which pointer will be incremented by 1? When we are talking about remove an item, remove, which pointer will be incremented by 1? In removing, yes, increment the front pointer by 1, right? And in adding, which one will be incremented by 1?
The end pointer.
Yes. So when you want to add an item, you have to increment the end pointer by 1. Okay, now the next question is, how is a linear queue different from a circular queue? Now, if I want to, students, add 2 elements, and we will observe the difference between a linear queue and a circular queue. If this is my if this is my question, if how, all right, so this is my question, right? Describe how orange and black are added to the queue in the diagram above, and we are talking about a linear queue. So what do you think? In the descriptive question, what is the first point that you will mention for adding orange? Yes, students, what is the first thing that should come to your mind whenever we are describing add an element to the queue? What is the first thing you should discuss? So the first thing should be check if the queue is full or not. So whenever we are adding, we have to check if the queue is full or not. So when the queue is full, when we are adding new items, students, if the queue is already full, then output error message. This is the first thing. Okay. So right now the situation is no, the queue is not full. So orange will be added at index number 9. And what will happen to this end pointer? End pointer will be incremented by 1 first. So increment the end pointer by 1 first and then add the element orange. Okay, now when it is the turn for black, and we are talking about the linear queue. What will happen, students? For black, adding black, what will happen?
Miss, would
Increment
there
end
be
of,
an error?
yes, it would be an error, right? So because end pointer is at 9, which is the upper bound, end is at index 9, which means the queue is all full. So for adding the element black, the result is output an error message. Black cannot be added because the queue is all full. So the difference between circular queue and linear queue is that in a linear queue, the pointers would only be incremented and there is no wraparound. So I'm writing it over here. In a linear queue, the pointers are incremented by 1 and there is no wrap around. Okay, there is no wrap around. This means that end will not go to index 0 to insert black because this is a linear queue. In a linear queue, the pointers will only be incremented by 1. They will just move forward, 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 and they will not be allowed to go back. And going back means wrap around. So what is the keyword? Wrap around. Okay. So I hope you're clear about linear queue. Now the answer
Miss,
is going to be yes. The answer is going
I
to be
had a
very different
question.
in the circular queue. Yes.
Miss, if this was a pseudocode, how would we decide if the queue was empty or if we could add another element or not?
Okay, so in a pseudocode, you will have the if condition. If end is equal to 9, then output error message,
Oh, okay, Miss. Thank you.
right? So this is a pseudocode. If end is equal to 9, then output error message. Okay, then students, okay, let me give you another scenario. In fact, okay, so if the question is, I'm changing the scenario, and if I'm saying, the question says end points to the next free space. Okay, and now this is another scenario. The question is about a linear queue, but end pointer points to the next free space. And this is the situation after adding 4 elements. This is the situation, right? So what will happen when you want to add orange? Now, when you want to add orange, what will happen? The first step is going to be increment end pointer by 1 or insert orange to the array. What is going to be the sequence?
Insert orange.
First insert orange, very good. First insert orange and then increment the end pointer by 1, which will bring it to 10. Okay? So let me just a minute. Let me arrange it. So over here, let me say first orange will be inserted. First orange will be inserted and then end pointer will be incremented by 1. End pointer will be incremented by 1. And now end pointer becomes 10. What is going to be a if condition for this question, for this scenario, when the question is about end points to the next free space, and this is a question about linear queue? What is going to be a if condition in your pseudocode? Yes, Mirza? If end is equal to, now we want to insert black.
Miss, if it is equals to the index plus 1?
Yes, which is 10. If end is equal to 10, then output error message, the queue is full.
Okay, Miss.
So there are two types of questions, right? There are two types of questions. One question is end points to the next free space. Another question is end points to the last element. So you have to look for these variations in the question, students. All right. So you have to look for the variations, whether the question is about a linear queue or a circular queue. This is one variation. And then another variation is endpoints to the last element or endpoints to the next free space. Your answers would change in these variations. Are you clear? Students, are you all clear? You have to look for
Yes,
these
yes.
variations. Okay, so the basics remain the same. The basics are adding a new item from the tail, rear, or end, and removing an item from front. But these are the variations of the question that you will look for, which are written at the top. Okay, so now I'm moving on to the next question. If I want to say this is a circular queue, right? So this question is about a circular queue. So now describe how orange and black are added to the queue in the diagram above. End points to the last element. We can see end points to the last element. How the data would be added. So the data is added not from front, it is going to be added from end. Always remember, in a queue, new people are added to the queue from the back, from the rear. Okay, and people are removed from the queue from the front. Okay, so now orange, yes. Should I increment end pointer first, or should I enter orange first, students? Please tell me. You can write it down in chat. Shall I add orange first or increment end pointer first? Yes, everyone keep answering. Yes, Faria, everyone keep answering in chat. I'm looking at your answers. Arish, please answer. Aisha, Balaj, please quickly answer in chat, everyone. Okay, yes, good. Increment. So this is what we will do. We will increment the end pointer first, increment the end pointer first, and then add orange. Okay, and now obviously in the descriptive answer, first of all, we will say check if the circular queue is full, then output error message. Otherwise, increment end pointer by 1 and then add orange to the array at index number 9. Now the next part of the question is add black to the queue. Now add black to the queue, and this is a circular queue. Yes, students, what's the next point? Circular queue.
Miss end pointer would now store 0.
Okay, so we are talking about add black. Okay, so whenever we are adding black, increment end by 1 if end is greater than 9, then what will happen? If end is greater than 9, what will happen? End is reset to, end will be reset to 0. Yes, so this is what we will implement. These are the steps that we will implement. So we will actually, we will increment end by 1 and it will go to 10, okay, because we want to add a new item. And oops, end is greater than 9, end is 10 right now. So what will happen? End will be reset to 0, and then we will say add the new item, which is black. Okay, so black is going to be added over here. So students, because this was a circular queue, so therefore it was possible to utilize the empty spaces over here. You have seen that linear queue is inefficient, it's wasteful, but we need to learn linear queue as well, because we do see questions about linear queue in the past papers, right? So this is how the answer is framed in a question of circular queue, which is very different from a linear queue. Students, are you clear about the difference now? Please tell me. Shall I move on? Yes? Are you ready to move on? Please keep responding in chat. Any questions? Okay, and you're most welcome to ask me questions related to these topics at the end of the class today as well. All right, and if you have queries about other topics, you're most welcome to send your queries to me. All right, so a variation I would like to discuss, students, if this question was end points to the next free space in the array. So where do you think are pointer would stop, end pointer would actually land over here then, right? If this was the question, end points to the next free space in the array, then this would have been the situation. Do you agree? Yes?
Yes, miss.
All right, let's move on. And now we will be discussing linked list, right? So linked list is, students, something like this. This is linked list. I'll do one question. Let me open another document. We will do one complete past paper question so that we can cover the table as well as the diagram as well as the description. This is an excellent descriptive question which includes a diagram, a table as well as description. So let me check the messages that the students have sent in. Okay, yes. Yes, Faria, add could be a keyword, add an element, insert a new element. You're right. And push and pop are only in stack. Okay, so over here, this is a past paper question. Students read so that we can start answering. Okay, and let me enlarge it for you, zoom in. All right, so okay, over here, always remember, let me just give you a quick introduction about the concept of linked list. In linked list, students, we have two pointers. One pointer is the start pointer. So this is the start pointer, which indicates the beginning of the start of the linked list with data in it. So these are the 4 nodes with data in it. And the other pointer is the free pointer. So let me write it down for you. This is the start pointer and this one is the free pointer. So we have 2 pointers which indicate the beginning of the linked list with data and the other one is free list. Free pointer points to the beginning of the free list. There are 4 nodes which are free, which means that they are available to be overwritten by actual data. So right now we have 2 null pointers. Always you will have 2 null pointers, students. Always you will have 2 null pointers in your linked list answer. One null pointer indicates the end of the data list. So linked list with data in it. And the other null pointer points to the end of the free list. All right. So always remember you have start pointer, free list pointer. You have one null pointer at the end of the linked list with data, another null pointer at the end of the free list. Okay. And now each node would have 2 parts. One part is the data and the next part is the pointer. So each node would have 2 parts. There are 2 parts of each node. One is the data part and the other one is the pointer part. So let's complete this table question which is given over here. So over here it says start pointer. What is the start pointer? Value of the start pointer. All the pointers are always integer data type and they store index value. So what is the index value for start pointer? We can see that the start pointer is pointing to D40 and D40 has been stored at index 4. So because of this, D40 has been stored at index 4, we can say that start pointer is at index 4 over here, right? So don't forget to fill this up. Then D32. D32 is at index 1. So for your working, you can always write down 1 over here, which indicates that D32 is at index 1. Then D32 is pointing to index 2. We can see over here, D32 is pointing to index 2. which is actually D11. So students, are you following? See, look at this information. It was given to us over here. D32 is pointing to index 2. So we have done our rough work over here. Okay, it is pointing to index 2. So what should be at index 2? It should be node D11. Node D11, right? And these are just labels. Labels D40, labels D32. This is not the actual data. These are just the labels representing the data. Okay, now in D40, what can we say? D40 is pointing to what index, students? What do you think? What should come over here? D40 is pointing to which index number?
1.
1.
Yes, very good. So D40 is pointing to index number 1 over here. So we can easily write down index 1 over here, which we are sure about. And then D40, I should write down index number. D40 is actually at index number. What should I write for index of D40? 4. D40 is at index number 4. So did you see, students? All the index values are not in sequence because of inserting and deleting of the nodes are jumbled up. Okay, so 4, 1, 2 we can see because of inserting nodes and deleting nodes, the index values of the nodes will become jumbled up, right? Okay, then students, we are left with just one node, which is index 3. D11 is pointing to index 3. It is given to us over here. D11 is pointing to index 3. And let's do a rough work and we'll say index 3 over here. So what node is at index 3? It is D100. So this is how we are filling up our table. And now D100 is pointing to which index? Which index are we pointing to? D100 is pointing to index 0. And you can write down null pointer over here as well, right? Null pointer is always going to be a value which is other than the valid index values. Please remember, students, null pointer can only assume an index value which is other than the valid index values. So if the index is starting with 1, the null pointer is 0. If index is starting with 0, null pointer will be -1. Please remember that. And even if you write down this null pointer symbol over here, that is also acceptable. All right, so both answers are acceptable. Now we start with the free list pointer. Free list pointer starts with index 5. This means from index 5, our free list is starting. Okay, and actually from index number 4, our linked list with data was starting, right? So here onwards, it is the free list. Okay, so now we can see that free list pointer is at 5, which means over here, I'll write down, I'm talking about this spot. So we know free list pointer is 5. And at index 5, we have F1 because free list pointer is pointing at index 5. So actually my identifier should be the same. Here I've just written shortcut start pointer. Actually the identifier given is full word start underscore pointer, and the identifier given is free underscore list underscore pointer. I've just written in a short form over here because of shortage of space. Because of shortage of space, I've just written shortcut free pointer. This is actually index number 5. So if this is 5, I'm going to write down over here F1, right? And F1 is pointing to F2. And over here we know F2 is at index 6. Good. So over here, I'll say this is index 6. And over here, I'll write down it is pointing to index 6. So all the pointers are index values. Please remember, okay, integer index values. Now, F2 is pointing to 7. And we know that this is going to be 7, which is F3. I'll write down F3 over here. Okay, and F3 is pointing to F4. We are just left with one space. So this means this must be F4, and F4 is at index 8. So I'll just write down 8 over there. And F4 is pointing to the null pointer. For null pointer, write down lower bound -1, which is 1 minus 1, which is 0, or we can write down the null pointer symbol as well. So this was the question of a table. And if you have a question of a diagram, so this is, students, how you have to draw the diagram of a linked list. This is in front of you. You must complete the name of the starting pointers, and you must complete the null pointers in your diagram, and look at the pointer arrow, which starts from the pointer part of the node. So this is one entire node. This is one entire node. I will write over here. This is one entire node, and it consists of data and pointer, and the arrow must come out of the pointer part. Okay, so you can be getting draw a diagram question as well, which is illustrate. The command word is illustrate, draw, or complete. So this means that this is what you have to draw. So let's move on. And this example is in your notes as well. Now, students, see in the marking scheme, it clearly says except 0, a null pointer, or out of bound index value, which is other than 1 to 8. So index values were from 1 to 8. Anything other than 1 to 8 would be a potential value for the null pointer, which is fine. Less than 1 or greater than 8, right? Okay, now this is another question that is a past paper question. So let's complete this. Okay, so the question says insert node D6. So this is what we're interested in. We are inserting node D6 between nodes D32 and D11. So keep underlining in your question paper whatever important points you have. So D6 will assume which node, which first free node D6 will use. This is the first free node which D6 will use. So first of all, let's copy the data D6 over here, right? So assign the data item dash to dash. So assign the data item D6 to which node? To
F1.
F1. Yes. And then set the dash of this node to point to this, of this node. So we are talking about this node only. Set the pointer of this node to point to which node? Set the pointer of this node to point to, कहाँ point करना चाहिए इसको? Pointer of this node to point to, actually this should be now pointing to D11 क्योंकि this will, D6 is inserted between D32 and D11. So this should be pointing to now D11. ठीक है? And D32 should be now pointing to D6, right? And this will no longer be there. So what are we doing? We are saying pointer of this node will point to D11 and set pointer to. What was pointer to? Pointer to was a free pointer. So it was the free pointer. What is the next free node, students? Which node is the next free node now, which is available to be used? Yes, now F2, you're right, F2 is the next free node. So F2 is the next free node now, all right? So F2 is the next free node. Set pointer to point to F2. And now set pointer of dash to point to dash. What is left? Yes, students, what's left?
Well,
Please write
the
it
point
down.
two.
Yes, please write it down in chat. What would be the last one? Set pointer of D32 to point to D6. And also students, it's better if I take out the pointer from here only actually. Okay, so I'll take out the pointer from this point, from D32. It should be like this, coming out of the pointer part and then going towards D32. So this was a past paper question, and now let's further discuss other sorts of questions. Any questions so far? Any queries? Okay, so another potential question would be, yes. So this is the question that I have made. I want you to delete the node. Okay, so delete the node. Which node is to be deleted? Delete node number D32. Okay, so when we are deleting D32, quickly students write down the first answer, the first blank in your chat window. Quickly write down. We want to delete D32, and the question says the deleted node is added to the head of the free list. The question says the deleted node is added to the head of the free list. This is not a past paper question, just a practice question. So this is your start pointer, and this is your this pointer, okay? And these are your null pointers. So what is going to be the answer of the first one? Set pointer of D40 to point to, yes, where do you think D40 will be pointing now after deleting D32?
D11.
Yes, you are right. D40 will be, now it will be pointing to D11 because D32 will be deleted, right? So yes, over here it would be D11, and then set pointer of D32 to point to, because this is going to be deleted, right? So D32 will be deleted, and now D32 will be pointing to F1. Because you see students, when D32 is going to be deleted, it will return to the free list. Now D32 is going to be deleted and it will return to the free list.
Miss, I
Now
had a question.
yes.
Miss, what do they mean when they say that the deleted node is added to the head of the free list? Should it be the last free node, like F4?
Okay, so D32 will be placed right over here. Let me show you where. D32 will be placed right over here, right? Okay, at the head. And D32 will
Yes.
be pointing to F1. And free pointer will be actually pointing to D32 now. So I'll make a new diagram for you and I'll just show you how this is going to work. Let me just show you. So over here, D32 will be placed. D32 will be placed right over here. And the pointers, I'll show you the pointers, how they will be updated. So this will be deleted. D40 will now point to D11 because D32 has been deleted. D32 will now point to F1. 1 and free pointer will point to D32. So what is the first free node now, students? Please tell me. What is the first free node?
D32.
Yes, the first free node is D32, right? And the question said the deleted node is added. The question said the deleted node is added to the head of the free list. They could have said the deleted node is added to the end of the free list, right? But this is the norm. In coding as well, this is the norm that the deleted node is actually the first node. So this is the norm, okay? So this one will be deleted. This one will be deleted. Are you clear about this new situation?
Yes, yes.
So let's complete set pointer of D32 to point to F1. And then D40 was set pointer of D40 to point to D11. So this is a practice question. This is not from your notes, not from your past papers as well. Set pointer 2 to point to, yes, pointer 2 will be pointing to
D32.
yes, D32. Are you clear about the descriptive questions, fill in the blank questions, or the diagram questions, students? Yes, please let me know.
Yes, yes.
All right. So now we are done with the revision of stacks, queues, and linked lists. The next thing that I want to revise is ByRef because I've been receiving queries regarding ByRef. Okay. So do you have any questions before I move on, students? Do you have any questions regarding stacks, queues, or linked lists?
Miss, can you please explain how do we check if the queue is full in a circular queue? Is it the same as a linear queue?
Okay, let me share my screen and explain. Good that you're asking questions. Yes, let me share my screen. So your question was how to check. Okay, one more thing. Yes, students, before I move on, please, Mirsab, remind me about your question. This is another thing that I wanted to revise regarding linked list. There are different data structures that could be used to represent a linked list. It could be, we know that a node would always consist of data part and the pointer part. So data part and the pointer part could be represented in the form of a record, and data part and pointer could be represented using two 1D arrays. One array would hold the data and the other one would hold the pointers. We can also have a 2D array. One column would hold the data and the other column would hold the pointers. And this is what the situation would be in case of an array of records. Dot data of the record would be one part of the node, dot pointer would be another part of the node, and this is an array of records. This is how it's going to be stored in the memory. And then this is two 1D arrays. Two 1D arrays, this is one array, this is another array, and the elements have not been arranged. Let's arrange them as well. And this is how a 2D array is going to be stored in the memory. So one column is going to be for the data, another column is going to be for the pointers. Now there is a variation. If the question is about ordered linked list, ordered linked list means that the data is in ascending or descending order, right? So let's arrange because this data has not been arranged yet. So these values are not correct. Okay, let's insert correct pointer values when the question is about ordered linked list. So there are two types of linked list. One is ordered and the other one is unordered. Unordered means that the data is not in ascending or descending order. And let's say if this question is about ordered, how will the pointers be updated? What is the, yes, students, what is the minimum data? So the start pointer, what do you think?
15.
Where is the start? Yes, so 15 is the smallest data item and the start pointer will start from here. This is going to be your start pointer, right? And let me make an arrow over here. This is going to be a start pointer, index number 2, right? And yes, what is the value that I should write in the pointer part of this? After 15 comes?
17, so 5.
Yes, after 15 comes 17. So it should be index number 5. So over here, I will write down index number 5. Students, are you getting how we are doing this? Index number 5 because the next value is 17. Now 17, what is the next value after 17? It is
22.
22.
So
Very
1.
good. So 22, it's going to be index 1 over here. Yes, and now after 22, it should be 4 because at index 4 we have 45 and the next value after 45 is 50. So index 4 will be leading to index 3. And now what is the value of null pointer, students? What is the value of null pointer? It is 0. Okay, 0 because lower bound minus 1. If the starting index was 0, our null pointer would have been minus 1. And what is the start pointer? What is the free pointer now? Free pointer would be actually is 0 null pointer because no free space. There is no free node in the array of size 1 to 5. Are you clear about this question, students? So you could have a question of ordered linked list or unordered linked list. All right. Shall I move on? Any questions? Okay. So I'm just checking your messages. Give me a minute. All right. So I was answering one of the questions from the students, and let me just clear everything. So students, this was a question in past papers. What are the data structures used to represent a linked list? Data structures would mean what are the kind of arrays or what are the kind of variables that will be used. So for variable start pointer, free list pointer, null pointer, they are all integer data type variables because they will always store the index values. And heap list pointer is mentioned in your textbook. Heap list pointer is the same as free list pointer, and heap is the free list. So this has never been assessed in CIs, but this terminology is in your textbook. Now, I was answering Mirsab's question. Mirsab, could you please repeat what was your question?
Is how do we check if the queue is full in a circular queue? Is it the same as a linear queue?
All right, so let's say if this was the situation, right? I'm adding more data and I'm adding more data to a circular queue. I'm adding orange and let me just move this. If I add a lot of data over here, okay, orange and let's say purple and blue. Right? So end pointer, where is going to be my end pointer? The end pointer will stop at actually brown, right? So this is going to be the situation. Okay, so number one, there are sometimes you have questions in which we have additional variable, which is length. Okay, what is the variable length right now? What is the variable length right now? What is the current value of length? Length is a variable in queues.
6.
Right now, variable length is actually 10. Okay, it was initialized to initialize length variable to 0, and when length was initially 4, it just had red, green, blue, and pink. So when length was 4, it had 4 elements. And now length is 10, 0 to 9 inclusive. We have right now 10. So if you have a variable length, in pseudocode, you will say if length is equal to 10, then output error message. Okay? So this is one way of doing it. Was this your question, Mirza? How to see if
Yes,
the circular queue is all full? Okay. And if length has not been given to us, so method 2 could be, we can say if front is equal to end plus 1, then. Okay? So this is what is happening over here. Front, the uh, the value of front is 5, which is equal to 4 plus 1, n plus 1. Then we can say output error. This is another method. This is method 2. And usually using the variable length is the easier method. Okay. So when we have the variable length, it becomes very easy for us to see, oh, the number of elements that could have been accommodated could have been 10 only. And yes, we have reached that limit. So right now there are 10 elements already, output error message. This is the easier method when we have the variable length in our question. It would be given in the identifier table, right? So this method is the easier one. And if we don't have the variable length, then alternatively, we can use this pseudocode. Mirsab, is it clear to you?
yes, miss. Thank you.
All right. So students, one quick thing that came to my mind, if x is assigned 10, if length is this equal to 10, what is the error here? Common mistake that I see in the test papers. What is the mistake in this particular if
Miss, shouldn't
condition?
it be an equals to sign rather than assignment sign?
Very good. This is a common mistake, students. This is a common mistake. So do not use assignment arrows in your conditions. You can only use is equal to sign in your condition. Okay. And also one common mistake that I see in the papers, less than sign. Do not use this less than and equal to sign, because this is not one of the keys on your keyboard. This does not exist in the subject of computer science, right? Okay, so are you ready to move on to ByRef? Because I have some time left and I was receiving a lot of queries regarding ByRef. Do you want to revise ByRef, students? Okay, so let me just open a new page for ByRef. All right, so over here, we are talking about ByRef. Parameter passing are of two types. Parameter passing could be by val or by ref. These are the two variations of parameter passing, and in by val, in parameter passing by value, the original data is not changed. Okay, the original data in the calling module, and module is subroutine. What is a module? A subroutine. By val, in by value parameter passing, the original data in the calling module is not changed, updated. Okay, and by reference, this is actually by reference. So actually, the original data in the calling module or subroutine is changed and updated. So the updated value is available to the calling module. So the updated value from So the updated value from the called module is available to the calling module. So students, if I have over here, let me explain it to you, what is going on. Okay, if there is module A, okay, this is module A, and it is module A has X is assigned to, right? And it is calling, okay, so it is calling B. All right, B module has been called and X has been passed by val. Let me just enlarge this by val. Okay, so by val X. Okay, so we are saying output X. All right, and A is calling B. So if I write down B over here, B has received by val X, and X is +1, right? And now it just, that's the end. That's the end of the module. Okay, so now what is happening? Module A, this is the header of module A, whether it's a function or it's a procedure. So see, this is header of module A, and X has been assigned value 2, and now B has been called, right? So over here, let me introduce a space. So B has been called, and obviously B would be a procedure because the keyword call has been used, and X has been passed as a parameter to B. So as soon as this executes, you know, students, that the control would jump from here to actually this particular header, right? And over here, this is what we have. We have the procedure header B, procedure header B. It is receiving X as a parameter of data type integer, and it has been passed by value, and after this we just say end procedure. Okay, end procedure. Now students, end procedure means that the control is passed back from end procedure. The control is passed back to the same line of call. This is what happens. Are you clear about this much? Now
Yes.
output X. In this case, look at output X. What will be the output at X value over here? This is going to be actually 2 only 2. What is output X? It is going to be 2. Why is it 2? Because it was by val. Because it was by val. So what was the definition of by val that we had discussed, students? The original data in the calling module. The calling module is A, right? So I'm writing over here, calling module is A, right? And called module is B. Do you agree with this? Calling module is A and called module is B. So this was the definition. The original data in the calling module, which was X, is not changed or updated. It would retain its value from here. X was 2 and output X would give us 2 only. Are you clear about by value? So whatever change the calling module made will not affect the original value in the calling module. Okay, so over here X remains 2. although it was updated over here, but the changes were lost as soon as end procedure executed. The changes would be lost. Now I'm going to show you the comparison, what happens in by reference. Okay, so in by reference, let's compare. This is the situation in by reference. Now, if I change this to by ref, what will happen? The output is going to be 3. The output is going to be 3 because it is by ref. Okay? The original data, so this is what we are focusing on. The original data in the calling module was 2. Now it was updated to 3 in the called module. So the updated value from the called module is available to the calling module. So the updated data 3 from module B is available to the calling module A. So now the output is going to be 3. Are you clear about this, students? So let's have a look at both. Let me try to fit both over here. Both the examples are in front of you. Have a look at this. When we have by val, all the updates are lost at the end of end procedure. And here in module A, the value of x remains 2. But when x is passed by reference, the updated value will be retained in the calling module A, and the changes that are made in the called module B will be retained in A as well. So the output is going to be 3.